Good morning, everyone. We're going to take a look at 9.2 together. So go ahead and take a look. Before you click on Start New Attempt, the video is there that we're making right now. Also, you can go ahead and open up your presentation that you're going to be using to answer the questions. You can do it here, or you can do it after you start a new attempt. So if you click on that, it's going to open up the presentation that you're going to use to get your answers here. So go ahead and open that up and click on Start New Attempt. And here we go. So first question we're going to go through is from slide 2. It says a rock is a natural current or solid mixture of one or more minerals or organic matter. So let's go through very quickly. I'll go through this one presentation with you and answer questions together. Types of rocks is the name of this presentation here. Let me get it big so we go through here. There we go. All right, slide 2 says what are rocks? A natural rock is a natural current solid mixture of one or more minerals or organic matter. Rocks are classified by how they are formed, their composition and texture. Rocks change over time through the rock cycle. All right, so for this one, hold on here, go back. Your question was for question number 1, a rock is a natural current solid mixture of one or more minerals or organic matter. That is the first statement there. That is true for that one. So we go ahead and pause and get that one in. So just so you know, you just talked about minerals last week. Rocks are basically a combination of all those minerals together. So they're naturally occurring solid mixture of one or more minerals. A rock can be just one mineral that's processed to become more of a rock versus a mineral. And also organic matter now can be put into the mix here also. All right. Igneous rocks is the first rock. We're going to take a look at igneous rock begin as magma. So this is basically dealing with volcano related. So magma that is inside of the earth. So this is melted rock. All right. Magma can form when rock is heated, obviously, and it turns into liquid rock. When pressure is released, it also forms. And when rock changes composition. So when the rocks are actually melted into magma, it can be several types of rocks in that area together, and then they're combining their chemical makeup to form basically new rocks, which is going to end up being igneous rocks. Okay. Magma freezes between 700 degrees Celsius and 1250 degrees Celsius. All right. Magma is a mixture of many minerals. So, yeah. So, of course, the magma has to cool. So it comes out of the volcano, turns into lava, because once it exits the volcano, it's lava, and it cools, it forms igneous rocks. Also, the magma can be seeping through vents underground, and it gets stuck in underground, doesn't ever make it to the surface, and it can cool underground also, and also form igneous rocks that way. So your next question was question 2. Magma can form when A, rock is heated, pressure is released, or rock changes composition. And the answer basically were all 3 of those. So D. Okay. Let's continue here. The next question comes from which slide? Slide 4. All right. Continue talking about igneous rocks. Let's look at some different types. You have something called felsic. It's light color rocks that are rich in elements such as aluminum, potassium, silicon, and sodium. You have something called mafic, which is dark color rocks that are rich in calcium, iron, and magnesium, poor in silicone. So you have, again, felsic and mafic. It depends on the type of volcano, the type of course, minerals that were melting and how they are actually cooled also. All this makes these different types of volcanic igneous rocks. Coarse grain takes longer to cool, giving mineral crystals more time to grow. Then you have fine grain, cools quickly with little to no crystals. All right. So your question here is, question 3 is fine grain igneous rocks are formed when the magma takes a long time to cool. So let's look at fine grain. Fine grain cools quickly. All right. So coarse grain is the long time. Fine grain is quickly. So that will be false for that one. All right. Next one comes from slide 6. do with slide 5. Here's some examples of igneous rocks, and notice how you go through each one, and it shows you basically the different composition makeup of all these igneous rocks, and see how they look totally different. Depends on the way they are come out, what they're made of, and how they cool down, fast or quick, or slow. Okay, that's felsic rock. Granite is felsic, and a mafic rock is going to be the other one there. Fine grain, coarse grain, you can see the difference between those two. All right, igneous rocks, again, extrusive igneous rocks, as magma pushes into the surrounding rock below the Earth's surface. All right, so intrusive means that it doesn't actually come out, okay? So the magma pushes and surround a lot but below, so they're stuck in chambers or vents that are not outside of the Earth. So intrusive igneous rocks are going to cool underneath the Earth's surface. Then you have extrusive, and that form was the magma erupts onto the Earth's surface, called lava now. It cools very quickly with very small or no crystals form. Okay, when it comes out, exposed to the air, it does cool off very quickly when that happens. Also, if it's exposed to the water, I mean, if the volcano erupts under sea, it also cools off very quickly also. All right, so this says extrusive igneous rocks form when sediments are deposited in layers with older ones at the bottom. Magma pushes into surrounding rocks below the surface, or magma erupts on the Earth's surface. Lava cools quickly. That would be the extrusive comes out, so it has to erupt. So that was going to be C for that one. All right, continuing on here. All right, this is an example of an igneous rock. This is obsidian. It is a dark colored glass. It's called volcanic glass at that point. That's because it cools very, very rapidly. And because it cools so rapidly, it doesn't have time to form crystals, right? So it's very smooth and glass in appearance. This is how obsidian looks. All right, sedimentary rocks is the next rocks we're going to look at. Sedimentary rock is formed by erosion. Sediments are moved from one place to another. Sediments are deposited in layers with the older ones on the bottom. And then the layers become compacted and cemented together. All right. So erosion weathering happens. It moves the sediments to another place. The sediments settle somewhere, and then sediments form on top of sediments, form on top of sediments, and then it becomes compacted, cemented together, and it forms the rock. Okay. Also, it may have some of the sedimentary rocks have some type of chemical reaction, chemical thing happening also to help to cause the cementation. All right. So this question says, sedimentary rocks is formed by erosion, true or false? And that is true. All right, some sedimentary rocks are formed at or near the Earth's surface. No heat or pressure is involved. Strata, these are layers of rocks. And as you can see from this mountainside cliff, you can see the actual layers. All right, that is on this side of this mountain. This is actually sedimentary rock. Sedimentary rock is actually awesome. You see the different layers between when this action was formed. Different conditions may have happened. So you actually see like the strata. Stratification, the process in which sediment rocks are arranged in layers. All right. Next one, all are true about sedimentary rocks except changes with temperature and pressure but remain solid. No heat and pressure involved. There can be layers of rocks called strata formed near the Earth's surface. All right, so that would be A. This is the one that's not true. Changes with temperature and pressure. There is no temperature pressure involved in sedimentary rocks. Okay. All right. Here's another example of sedimentary rock. This is breccia. I think how you pronounce this. It's a term often used for clastic sedimentary rocks that are composed of large angular fragments over 2 meters in diameter. The spaces between the large angular fragments can be filled with a matrix of smaller particles or a mineral cement that binds the rock together. As you can see in this example here of this rock, they're large chunks and then they're filled in by smaller granules of sand and stuff, and it's all compact together and makes the rock look very coarse and fragmented. Okay, very coarse and fragmented. Classic sedimentary rocks, question number 7, are made of minerals crystallized out of solution to become rock. Did we say anything about minerals out of solution? I don't think this is this type of rock. So that's going to be false for that one. All right, let's continue here. Limestone is what I was talking about. This is the false for the question we just saw. Limestone has to do with now taking a substance that's the water is whatever chemical acid base or whatever in the water, and it's going to solidify and compact the actual sedimentary rock. Limestone is a perfect example of this. It's a picture here. Notice how the difference between limestone right here looks versus the other sedimentary rock. Totally different looking, right? This because this is composed primarily of calcium carbonate in the form of the mineral calcite. It most commonly forms in clear, warm, shallow marine waters. All right. It is usually an organic sedimentary rock that forms from the accumulation of shells, coral, algae, and fecal debris. So this is from basically a compaction together of dead organic material from those animals right there, the shells, and they've basically been beaten down to like almost sand, and then they come together and form. Chemical sedimentary mineral was crystallized out of a solution to become rock. This is coal. Coal is another type of sedimentary rock. Is organic sedimentary rock that forms from the accumulation of reservation of plant materials, usually in a swamp environment. So coal that we use basically for electricity, and that type of thing, and actually, so it's combustible, meaning it basically catches fire easily. It's because it's made from organic material, so from dead plants, animal materials that have basically been formed. That's basically what that is. Organic sediment remains of plants and animals. All right, metamorphic rock, next rock, meaning to change shape. That's what metamorphic means. Changes with temperature and pressure, but remains solid. So temperature and pressure has all to do with this formation of rock. Usually takes place deep within the earth. Not so deep that it turns to magma, but deep down right before that, okay? Here we go. Question number 8. All are true about metamorphic rock except meaning to change shape. Usually takes place near the Earth's surface, changes with temperature and pressure, but remains solid. Usually take deep place in the Earth. B. It does not take. This is not metamorphic. It's nowhere near the Earth's surface. It's always very deep. Okay. All right. Let's continue here. Let's just see what next was. Okay. All right. Here's some examples of metamorphic rocks. Hornsfels is a fine grained, non-foliate metamorphic rock produced by contact metamorphism. Contact metamorphism is heated by nearby magma. So like I said, this rock is so deep inside the earth, is right before it turns into magma. So this rock is actually, the heat it gets is from deep inside the earth, from magma, excuse me. Increased temperature changes the composition of this rock. Minerals are changed within new minerals. All right, next one here is regional metamorphism. Pressure builds up in rocks that is deep within the earth. All right, where you have large pieces of earth crust collide and the rock is deformed and chemically changed by heat and pressure. So also this heat and pressure can be like the plates moving or hitting each other and pressing together. That can also cause formation of metamorphic rocks. All right. Gneiss is an example of foliated metamorphic rock. True or false? I think gneiss was on the previous slide, was it not? No, I think it's on the next slide. Yeah, here you go. Gneiss is foliated metamorphic rock that has banded appearance and is made up of granular minerals grains. So gneiss is a fully foliated metamorphic rock. That is true for question number 9. All right. Notice how metamorphic rocks are going to be your more smooth rocks, as far as like the composition is, because of all the heat and pressure, is going to be the more compacted, not easy to break off. Sedimentary rocks, like as you can saw, are also can be smooth, but they're easy to break off or crack. All right. Your metamorphic rocks are going to be your very hardy rocks, okay, because of the heat and pressure. Foliated, which means that grains of flat minerals. So it's not so small pieces that come together to make foliated rocks. Then you have marble. Marble, of course, most known for making statues and also countertops and things of that nature. This is a non-foliated metamorphic rock. That means minerals are arranged in planes or bands for that. I think that's your last question here. Marble is an example of a non-foliated metamorphic rock, and that is true. All right. I think that is it for this. Has some actually some examples here of foliated and non-foliated. You can determine which one is which. Okay. So you can go through and just look at those and you can guess which one is foliated, which one is non-foliated. All right. All right, that's it. So go ahead and make sure you submit your answers and let me know if you have any questions about anything also. So have a great rest of your day.